This is pre-calc 2.7 day 2. We're going to start off with method 2 of maximizing or minimizing quadratics, aka parabolas. So, what we're going to do on this one is that it gives you the quadratic in standard form. The book calls general form, if you remember that from yesterday, ax squared plus bx plus c. What we then just need to use is the nifty little formula right here. And we've all used that before. X equals the opposite of b over 2a, which finds the line of symmetry, and we know that the vertex lies on the line of symmetry, and so therefore our maximum or minimum value of that said parabola will be on that x value. I put that x value in, I'll get a value out. Remember, there's a difference between finding the vertex and finding a maximum and minimum value. The vertex contains the value at a particular x value. So be careful, because that's the way we're going to state things today, and we have been stating. So, we know that if a is positive, just like before, then we will have a minimum problem. If a is less than 0, it opens down, which means we have a maximum value. And what you kind of probably can't see in there is that it's taking the x value of opposite of b over 2a and plugging it into function notation. So it's f of negative b over 2a, right? Function notation. We're all good with that. And so let's do these two problems below. They're in standard form, aka the book says general form. We just need to find the maximum value. So for me, I like to list A, B, and C. We did this before when using the quadratic formula. I will do it again because the more information I have, the more information that I'll be able to use to say, am I right or wrong? What's A? The problem is f of x equals x squared plus 4x. So A is definitely 1. What's B? And C? 0. Do we even need C? Not for this particular problem. But guys, I could use the quadratic formula, I could factor, I could complete the square, and I could solve for my intercepts. And my y-intercept. And all of those different things, these are all going to be pieces that are going to allow me to graph this and have a better understanding of what's going on. Also looking at this, is this going to be a maximum problem or a minimum problem? Maybe before we even say that it's going to be a minimum problem, this will open up. So therefore we will end up with a minimum, yes? That kind of leads us to believe that this is a minimum problem. And now, if I'm going to use a formula, I will write it down. So opposite of b over 2a. So that means that is the opposite of what? 4 all over 2 times 1. Which happens to be negative 4 over 2, which is negative 2. Did I answer the question? Why is this not answering the question? What do I really need? I need to have the actual value, the minimum value, which does occur at negative 2. So guess what? Use function notation, and I evaluate that function above at negative 2. I'm hoping that actually the last 2 days of lessons pretty simple, stuff we've done before, and it all makes sense. So I get negative 2 squared plus 4 times negative 2, which happens to be negative 2 squared plus a negative 8, or just minus 8, which equals negative 4, correct. Does that answer our problem? Why not? It says find the max or min value at each quadratic function. Technically, negative 4 is the answer, right? If I had this problem in the book, and I probably looked in the back, That's what it's going to say. It's just negative 4. But to get us a better understanding, so if someone walks in the door and takes a look here and says, what are we looking for? I would love for you guys to write this. Minimum value of negative 4 at what? Negative 2. We have a minimum value of negative 4 at negative 2. This expression right here has a lot packed in it. Can you guys tell me the vertex? What's the vertex? Just looking at that. Negative 2, negative 4. You can tell me the minimum value and when it happens, which is the vertex. Here's a cool thing, guys. Knowing this and looking at the standard form of the equation, could you actually write the vertex form really quickly? The answer is yes. You have an A, you have an H, and you have K. What's A? It's 1. What's H? Negative 2. What's K? You guys should be able to write y equals A times the quantity x minus h squared plus K. Any questions to that? Next one, A equals B equals C equals. What's A? It is negative 2. It's a little hard to see on the screen there, but it's negative 2x squared plus 4x minus 5. So B is 4 and negative 5. I'm glad that I am not hearing at this point or this level that it's 4x or it's a negative 2x squared is A. Because remember, your coefficients are the A, B, and C. This is opens which way? Down, which will lead us to having a maximum value. And so now I can do x equals the opposite of b over 2a. Yes, I'm using it, so therefore I'll write it. What is the opposite of b? What's b? 4. A. Negative 2. So the opposite of 4 is negative 4. And 2 times negative 2? Oh, so it's just 1. Now what do I do? Half of 1. So it's negative 2 times 1 squared plus 4 times 1 minus 5. 1 squared times negative 2. Negative 2 plus 4 minus 5. We will end up with the value of negative 3. So the answer to this question should be stated as what? Everybody should be trying this, hopefully writing some things down. We would say it's a maximum value of at 1. And if you want to say x equal 1, that's fine. Or maximum value of y equals negative 3. Those types of things to help you establish that, hey, we do have a vertex at 1, negative 3, but it's also got a maximum value of negative 3 because it opens down. So, this one's about gas mileage on a car. Very important nowadays. It says most cars get their best gas mileage when traveling a relatively modest speed. I think the last time I heard that gears were supposed to be, cars were supposed to be geared for like 55 miles an hour. I don't know for like the optimum gas mileage. This problem actually is going to be a little different, but we all know we don't go about 80, so probably not getting the best gas mileage, guys. in our cars. You probably can look this up online for your particular model of a car. But it says that the gas mileage M for a certain, I said certain twice, for a certain new car is modeled by the function m of s is equal to a negative 1/28 s squared plus 3s minus 31 from the speeds of 15 to 70, where s is the speed in miles per hour and m is measured in miles per gallon. What is the car's best gas mileage, and what is the speed that is obtained? Wait, what do you mean by the car's best? So we're going to try maximizing this or minimizing this? We're trying to maximize gas mileage, right, at a particular speed. So this is no different than the problem before. It's just got not so nice numbers. Whoop-de-doo. I think we can handle that. So we still want to list what's A, B, and C. Yeah, it's a negative 1/28. B is a nicer number. It's 3, and C is negative 31. Again, I'm listing all of them just in case I do need them. Okay. And now we just have to, well, maybe before we use the formula, we just said we want to maximize because it opens down, right? So x equals the opposite of b over 2a. I'll give you guys a couple seconds to do the math here, fill this in, and then we'll come back together. Okay, we should be almost done, I would almost think. So, filling it in, opposite of 3 over negative 2 times negative 1/28. Negative makes a... Wait a minute. Why do I have a negative on the bottom, guys? I don't know. Jackson told me to put it there. Okay. So, let's actually, a negative of a positive keeps this as negative 3. A positive times negative is a negative 2/28. But a negative makes a positive when dividing. So now, wait, I can reduce that yet. That's 3 over 1/14. When you're dividing by a fraction, you will. So it'll be 3 times 14, which is 42. What is 42? Actually, that's not even, maybe we shouldn't even use x. We should be using what? S. So let me take that out of there. That's just, it's not overly important, but know that our letters are variables that we were using with S. What does that S stand for? And it told us that it was in miles per hour. So this particular car gets its best fuel mileage at 42 miles per hour. All I know is that I'm going to Florida next summer, and I guess I will be traveling 42 miles an hour to get there. It'll take me about, what, a day and a half now? Instead of 24 hours, it'll take like 30. No, I'm not going to do that. But that's what this would kind of tell you, right? The slower your speed, possibly, potentially, this might be a good idea. But is that the answer to our question? Yes and no. It's a yes because it wants to know the speed you need to go to attain it. But that is the speed, so now we need to go find out what the actual mileage is. And we do that by, again, plugging it in. Plug it in, plug it in. So negative 1/28 times 42 squared plus 3 times 42. I am not going to do every single step on this one. I will let someone tell us the miles per gallon at 42 miles per hour. And what does it happen to be? 32. 32 mpg, miles per gallon. So to answer our question, we would state it how? The maximum miles per gallon, oh, not miles per hour, miles per gallon of 32 is attained when Driving what? 42 miles per hour. Okay? Not so bad, is it? So the last thing that we're going to talk about is what happens if I don't have a quadratic. Both of these problems are cubics. We could have something to the 4th power, 5th power, 10th power, 100th power. What you'll find, guys, is that graphs will start to have more changes, right? We've all seen the graphs of cubics and stuff. Most cubics have a pattern that looks like this. Both of those will have a pattern, something very similar to this. You guys can agree with that because they're both cubics. If it was something to the 5th degree, it would have to be something like this. Some shape or form. But what we're going to say, guys, is that there still can be something we call a max and a min. But the question or the problem we end up having, though, is the fact that these graphs go on forever. And so if it keeps going up forever, as soon as you say, hey, look, there's a maximum point right here, I'm going to tell you there's another one right here. And then there's another one and another one. So there really is no true max, right? But if I look here, this is the highest value within the graph. So we call that a local max, and the one down here we call a local min. So let's state that. So we have local max and a local min. And the local max or the local min is your highest or lowest point within a graph. So obviously if I'm looking at my 5th degree one that's down below, and you guys can use Desmos. Desmos basically gives you the point at all the high points and low points. You guys have seen that before. If I'm looking at this one, it looks like this point's higher than the other. So this one here is the local max. And this one, I would say slightly lower than the other, is your local min. Can you guys see that? Okay? They're very, very rough drawings. I know this. So I'm going to pause the video, and we're going to go to Desmos, and we'll graph x cubed minus 8x plus 1, and we'll just show you guys how Desmos can help you guys. So day 2 is page 205. Let's do 39 through 44, 50, and 54. Have a wonderful, fantastic, great day.